The main limitation of the previous method is that even though we get the autoregressive coefficient and we use the GLS method, the autocorrelation might be still present in our final results. And because of this, we need to have some other procedure to deal with autocorrelation. And one of them is called Cochrane-Orcutt iterative procedure. And it looks in the following way. So in the first step, we run the original regression and we get the estimated residuals. After this, we we run the regression of the estimated residuals in the current period on its lagged value to obtain the estimated ROR coefficient. So this is actually this method. So after this, we use the estimated autoregressive coefficient to transform the variables and run the following regression. So this is the GLS, the generalized least squares estimator. And if Darwin-Watson test showed that autocorrelation is still present in the new regression, we need to repeat the procedure from the third step. So what we do is we save the estimated residuals from this regression, right? So the estimated residuals from the new regression. And we take those newly estimated residuals and we regress them on their lagged value to obtain the new estimated autoregressive coefficient. Now you see it comes with two heads. So we take this estimated autoregressive coefficient and we transform the variables once again. So this is the traditional GLS method, which can be also written in the following way. And if it happens the Darwin-Watson test still shows that autocorrelation is present, we need to repeat the iteration. And we keep on repeating it till we solve the problem of autocorrelation or till the following happens. So if Darwin-Watson keeps on showing that autocorrelation is still present after a number of rounds, we stop when the estimated autoregressive coefficient from the previous iteration when the newly estimated autoregressive coefficient minus the autoregressive coefficient from the previous iteration is only different by 0.01. So when this happens, we need to stop and just accept the fact that we cannot solve the problem of autocorrelation using this procedure. So once again, when the difference between two estimated autoregressive coefficients is negligible, like less than 0.01, then in this case we stop the iterative procedure and we just accept the fact that the procedure is not able to help us with autocorrelation and we probably need to use another method. And the last method that I would like to present is new US standard errors. This method allows us to obtain consistent estimates of the variances and covariances of OLS estimators. So once again, this procedure is very much similar to the case of heteroscedasticity, but this time we will use another type of standard errors called new US standard errors, and actually the beauty of them is that they are both heteroscedasticity and autocorrelation consistent. So those standard errors account for both heteroscedasticity and autocorrelation. And most econometric softwares include the possibility to use those standard errors, so you don't need to worry about them. However, please keep in mind that this procedure, that the new US procedure, is valid only in large samples. So if you have a small sample, unfortunately, you cannot use this procedure. So it's not valid in small samples.